So let's start by talking about the classifications of matter. So in this one, you will learn ways of classifying matter, and the next would be that you will also learn how mixtures of matter can be separated. Okay? So you learned that matter may be classified according to its physical state, which may be solid, liquid, or gas. Each physical state has properties. These properties are explained by the particle model of matter. In this chapter, you will learn other ways of classifying matter. You will also learn how mixtures of matter can be separated. Okay? So right now, we're just going to focus on pure substances, mixtures, and the types of mixtures. So we have here our chapter concept map. Starting with matter. Matter may be classified as two things. May it be a pure substance, or later would be a mixture. So let's start first talking about what pure substances are. Pure substances such as element or compound. Next would be mixture. We're going to talk about this one at this side. That would be how mixtures are going to be separated. But first, we're going to focus on pure substances and mixtures for today. So mixtures may be classified into three. A homogeneous may be in the form of a solution, consists of solute or solvent. Next is heterogeneous, that includes both suspensions and colloids. Mixtures may be in the part of colloids that consist of dispersed particle and dispersing medium. Okay? So going back, it's going to be a bit much, but don't worry, I'll make it very simple for you guys. No? I think the others would already remember what's the difference between a pure substance and mixture, but let it be known that knowing these kinds of solutions, suspensions, and colloids will tackle later and how we're going to understand them specifically. Okay? So here's what I'm for naman eh. That's why I'm the teacher. I'm going to give you the simplest way on understanding how these things work. Okay? So let's start first with pure substance. We're already on page 35. So pure substances, let's start first with pure substances. There are two things, the elements and the compounds, okay? The compounds are called pure substances. Pure substances have fixed composition and properties, okay? Now, let's talk about first what an element is. An element is the simplest type of a substance. Now, each element has physical chemical properties. Now, like iron. Iron, ano bang properties ng iron? Iron is a metallic solid, conductor of electricity, attracted by a magnet, and reacts with oxygen. Okay? That's what we call some of the chemical properties of an element. Okay? Single elements. Another one would be basic would be oxygen. No? Oxygen is odorless, colorless, tasteless, and reacts with iron. Reacts with iron might be like that oxygen when interacting with iron turning into rust. Diba? Nagra-rust yung iron lalo na kapag nahahanginan siya ng matagal. Okay? Now, what is a compound? Compounds are a combination of elements or atoms of different elements can combine to form compounds. This as well as these examples, common chemical compounds that we have. Water, ayan, hydrogen and oxygen, ammonia would be nitrogen, and 3 hydrogens, carbon dioxide, hydrogen peroxide, and these are examples of compounds. We have a lot of compounds to talk about, but these are just some of the common compounds that we have. So in your book, this as well as very specific that there are also characteristics here, elements, and how they are differentiated by melting point, boiling point, density. So all of which are located in your book. So again, I'm just making it simple for you guys what to remember in this lesson. So next, after pure substances, we're already on page 36. So turn to page 36. Now, it consists of two or more substances combined together in no fixed or definite composition. So what am I talking about? So how do we know if this is a mixture? Okay, so I'm just going to give you a couple of seconds to think about why this is an example of a mixture. Okay, so almost everything around us are made out of substances that are physically combined together to form a mixture. Like this one, Minute Maid Premium Original Orange Juice. Okay, and it says it's 100% or 100% orange juice from concentrate. So you may say that this orange juice is a pure substance because it's 100% orange juice from concentrate. No. So how do we know if this is a mixture? So orange juice drinks are mixture of orange juice powder, well, some of them, and water. Would you consider this orange powder as a compound? Why or why not? So if you read the label of the juice powder, you will discover that the orange powder may have at least two or more components. May it be not a powder or just a concentrate. You will see that there are other components. I think this one was already mentioned in the fewer grades on how you're going to read the nutritional facts. Now you can see that there are also other things that are located or other things that are present in the orange juice. So you can see that it's a mixture already. Look at this one. Sodium, protein, vitamin C. Some of them, we can say, sodium. That would be an element combined with other sugars. Sugars is a compound, no? And other things. Okay? So we can say that this one, this concentrate, or maybe a powder, is going to be considered as a mixture. So let's try this activity. This is also present in your book, but better, no? If you try to answer it with me, and just as well as write your answers in your book. So as an activity, examine the pictures that and classify the object of as pure substances of mixture. Write your answers on the table on page 37. So I forgot to put the pages there. So it's page 37. So marshmallows. What do you think they are? You may pause this video and try to write down your answer. Or if it's live, just write your answer right away. So this one would be, spoiler alert, it's a mixture. Again, this one, salad, very easy. Okay? That would be, of course, a mixture. And an example of a diamond, is it a pure substance or a mixture? Is it a pure substance or a mixture? Diamond, for those students who are still playing Minecraft, it's a pure substance. A gold. What about gold? Which is present in the periodic table. The periodic table is composed of the elements, remember? And elements are pure substances, right? Lastly, two more, sorry. Salt. Salt. So salt, how is, if you can remember the episode of Jimmy Neutron, he says to this guy, when he was working, it's sodium chloride. Then the other guy says salt. Sodium chloride, so it's a chlorine, and sodium would be meaning that compounds are a pure substance. Okay, so again, elements and compounds are pure substances. And lastly would be water. Everybody knows the chemical composition of water. And again, water would be a mixture or pure substance. Pure substance, diba? Okay, let's go to the types of mixtures. So there are two types of mixtures. So let's turn our page to page 38. So time to time, I'm also going to look at the book so that we can really follow. So we have two things. We have the I'm just going to move my camera. Yeah. All right. So meron tayong homogeneous and heterogeneous. Okay? So I'm going to explain it in the next slide. So let's talk about the meaning first of both. First, we're going to talk about what the difference between the homogeneous and heterogeneous is. Okay? So homo means the same and hetero means different kind. So when we talk about mixtures, homogeneous mixtures are the same and heterogeneous mixtures are different kinds. All right. So next would be some of the examples that are here called heterogeneous mixtures, which are particles that are distributed uniformly. Yan. Tulad nga ng cereal in milk, ice in soda, blood, soil. Next is homogeneous mixtures. So let me move my camera in the middle. There you would find that an example would be alcohol, air, rain, and steam. You can see that homogeneous mixtures have particles distributed uniformly compared to heterogeneous mixtures. Okay. Now, let's move on to solutions and suspensions. Already on page 39. All right. So just ignore this one. This particular thunder in the milk. It's irrelevant in the picture. So let's start first with solution. No? A solution is a homogeneous mixture which contains different components, but their particles are too small to be seen. Now, there are two important parts of solutions. We have here the solute and solvent. So what are the differences between the two? A solution has two important parts. A solute is the substance that is being dissolved. Most likely these are smaller amounts when dissolved into a solvent. So what is a solvent? A solvent is the one or the substance that dissolves the solute, which is always going to be the larger amount. Okay? So you won't be able to dissolve a lot if you have less amount of solvent and more amount of solute. Though it's going to be dissolved, but it's going to dissolve everything from the solute. Now going back, solute should be in the proper small amount compared to the solvent supposed to be having a larger amount that needs to dissolve the solute. Okay? Again, the solute is going to be dissolved and the solvent is the one that dissolves. Okay? The solute. Okay? Now, there are also things that are located in your book. These are types of combinations of not necessarily liquid and solid combination that dissolves into something, but sometimes a solid and solid can also become a solute or solvent. Like for example, in your book, there's a solid type of combination. Copper and zinc. Copper and zinc combined together would turn into brass. Solid to liquid combination, that would be juices or coffee grounds combined with a solvent of water. Okay? Next is liquid to liquid. Okay? Liquid to liquid solute. Solute would be the acetic acid for the combination combined together with water, that would be the solvent, turns into vinegar. Gas and gas combinations are also possible. That would be oxygen and nitrogen turning into air. Okay? Gas to liquid. Gas and liquid together. The solute would be carbon dioxide. The solvent would be water. That would turn into soda water, diba? Or soda. So this is what's important in knowing what solutions are. Okay? The solute and the solvent. Now, a solution, again, is a mixture formed when one or more solutes dissolve in a solvent. Okay? And this is what is the common example that we have here. Sugar solution. Okay? Let's move on. After solutions would be suspension. Now, I want you to look at this example here. So, I think in some science videos in Facebook, or if you watch, I think he's very famous. If you don't know him, he's the crazy Russian hacker. He's also playing sometimes with some science experiments, just like this one. You can see that there are types of suspensions here. Others are suspended from one another. So what are they? Now, suspensions consist of particles that do not dissolve in a liquid solution. That's why vegetable oil, water, dish soap, corn syrup, and honey, in this example, on page 39, is not mixing together. Well, you can try to mix them together, but they're not going to dissolve in a liquid solution. So, some of your parents or you guys already use these kinds of stuff. Now, this is important to understand what suspensions are, just as well as this one. Because suspension consists of particles that do not dissolve na, diba? Meaning, oil and water do not mix. Oil is less dense than water, which causes it to separate and float on water instead of dissolving. Sand in seawater is another example. And more substances like this one, like the dry spray. This one is a medicine. So what do you usually do before you use the medicine or a dry spray? Okay. So if you have it in mind that it's going to need to be shaken well before using, because it creates suspensions inside. Okay. So you're not going to really maximize the use of the medicine here and the dry spray without without shaking them very well. Because again, going back, suspensions consist of particles that do not dissolve in a liquid solution. Okay, this just remains suspended. Going back to the picture. Okay. Now, lastly would be colloids, which is on page 40 and 41. Now, there are also examples here of what colloids are, but making it simple for you guys, colloids are mixtures whose particles are larger than the size of the particles in a solution. Again, mixtures whose particles are larger than the size of the particles in a solution and smaller than the particles in a suspension. So I'm not going to expect you to understand it immediately. So we're going to have examples here. So checking your book, you can see that the example there would be milk. Okay. So going back to the colloids, colloids have two components. Okay. Before explaining it a bit further and let me understand how it works, that has two components. So if we try to remember our concept map earlier, we have two components of colloids. Now, one is dispersed particles, and the other one is the dispersing medium. So in dispersed particles, particles that are spread out through mixture, for that one, and dispersing medium would be the substance in which the colloidal particles are distributed. So let's check the book. So what are the examples here? Okay. So a colloid, again, colloidal, dispersing medium, we already tackled that. Milk powder is dispersed dispersed particle, and water is this dispersing medium. So here's an example of that one. So it's like a solution, solute, solvent, right? But if you look at this picture, how do we observe these things? So if we try to mix together, for example, Milo, Ovaltine, and other milk drinks, right after mixing, you'll eventually, if you don't drink it right away, you can see that there are other formations that you can see under. No? Now, again, in this example, would be the milk powder is the dispersed particle and the water is the dispersing medium. The dispersing medium is always going to be greater in quantity than the dispersed particle. Now, particles of a colloid are continuously bombarded by other particles. Thus, they do not separate from mixture and settle down at the bottom of the container when allowed to stand, meaning you're going to move it. So eventually, you already experienced this one. Okay, if you're trying to freeze something like your orange juice drink or your Milo drink, if you want it to be eaten frozen or drunk frozen, usually all of the sweet parts are at the bottom, right? Again, they settle in the bottom. We're still talking about the colloids here. They settle at the bottom when they are allowed to stand. So if you're not just going to move, then they're just going to settle at the bottom. So this is how colloids work. Okay. And another one would be examples of colloids at the bottom of your book. You may try to read them in your free time. So you would know some of the examples here. So it would be a little bit too long for me to discuss all of these things. So these are just examples of how things are separated from dispersed particles, dispersing medium, and what phase there are. So let's try to talk about some examples here. So one example would be an aerosol. It would be like the Lysol, okay, perfume sprays. So it's a phase of gas phase. The dispersing medium would be, a dispersing particle would be the liquid, and the medium would be the gas. Examples are fog, clouds, and perfume sprays. So you may read on your own on page 40 and some of the examples of these colloids. Okay? Now, colloids are also very important. Now, what are the uses in daily life in page 41? Like, for example, medicine. Some medicines are also part of suspensions. As earlier as we mentioned, shaking it would be maximizing the greater use of these medicines. Some of these things are made out of colloids, not specifically these examples, but some of them. Now, medicines in colloidal form are more effective because they are easily absorbed by the tissues of the body. There are also food. Like, for example, you like to eat salad. Salad is not, it doesn't really taste good. Well, for me, if it doesn't have mayonnaise, but for you guys, if just want to eat just a plain salad without the mayonnaise, it's also part of making colloids better, in foods, in medicines, as well as other examples. Like the gelatin, the butter, the whipped cream, marshmallows. Some of these are clouds and fogs. Okay, these are examples of colloids. So to sum up the differences between the solution, the suspension, and the colloids, that solutions, example here would be salt, dissolves in water, forms a uniform solution, meaning yung salt, the salt is going to be the one to be dissolved. That would be what we call a solute. Then the solvent would be the one that dissolves the solute, right? Suspension is an example here would be flour. Flour is suspended in the water, has a blue cast from the light scattering of our flour particles, as you can see here. Suspended, again, meaning it doesn't really interact with water. Okay? The one that does not dissolve in water is a suspension or liquid substance, not rather water. And another one would be a colloid. Would be milk that contains butter fat globules dispersed in a watery liquid. So once it's settled down, it goes down. Okay. And you may also experience some of these colloids when these butter fat globules are also already in a bad state, expired rather. Okay. So let me just add that, of course, milk can also be turned into butter to turning into another type of colloid. That's one example. Let's move on and try to finish. Now, going back to our concept map, we've already tackled or classified some of the differences between the pure substances, such as it is an element and a compound. Mixture would be, this one would be separated from our other topic, because that one is separation of mixtures. That may be classified into a homogeneous, heterogeneous, and colloid. So a solution is a homogeneous, is composed of a solute and solvent. Heterogeneous would include suspension, and colloids that consist of dispersed particle and dispersing medium. Okay? So thank you again. This is Sir Kevin Pimentel, your science teacher for this year. Okay, bye.